Okay, so this is my element 21 external walls from the passive house measure. So this is the second in the series. If you haven't watched the first one, please go back and watch that. And also please watch the importing drawings and setting up projects one. I wanted to show you this mistake because I'm constantly making this mistake with these drawings. The default section, I'm used to the default section being vector. In most cases, vector is actually okay, but in some cases, it's not. And so if you're in a hurry sometimes and you load up drawings and you see all this text like this, where it's all kind of on top of each other and it's very, very difficult to read, don't panic. Chances are you've just clicked the box and import it very quickly. So you have to manually select raster every time. So just remember to do that. So I'm just going to click into another version here on this side. The little I over there, by the way, indicates that's the one that's currently under view. Depending on your version of Cubit, you may have 2 or 3 drawings that are available to view at any one time, but if you click on them, you can see them. So in this case, I just click on that and I can see it. So that's my ground floor plan looking a lot better. Also, as I'm coming up to assignment and exams, I'm thinking of how to do things quicker. So one quick way, because element 22 is very similar to 21 and we've all the same drawings, one quick way to do that is just set up your drawings first of all, X out of it, go back to your project manager screen, job manager screen, and where you have element 21 there with all the drawings, just copy that and back in there, paste. So you should have 2 element 21s, and then you can rename that element 21. You can rename it to element 21. Sorry, element 22. I didn't mean to. I was trying to save that, rename it. Didn't mean to X in. 1 second there. This is all live, guys. Okay, so I'm just going to click in here, and I'm going to call that element 22, internal walls. So that way you save yourself a bit of hassle. So now you have all your drawings set up for internal walls as well as for external walls. Okay, so I'm going to go in and now and do my external walls. I'm going to, again, this is an abridged version. So in the class, we wrote out a list of all of the possibilities that we could be measuring. It's called a two-take list, and we got that from the note in the content section, the Tony Cunningham guidance note on element 21. And we ended up writing a big long list and then only measuring a handful of items in the list and then deleting all the items in the list. Rather than doing that today, I'm just going to focus on what it is that we are measuring. So I'm going to type that information in here now. Pause this video for a second. Okay, so we've had a little look at our drawing, and essentially because our drawing is a single leaf, we have external insulation, which is our wall finish, which will be measured separately. We don't have any of those labours that were listed out in Tony's to take off sheet. So we essentially have block walls, concrete lintels, steel lintels, 3 items to measure. That's it. And a query that came up the last day in class was in terms of vertical area. Up until now, I've been teaching this in vertical area. Vertical area is probably the most correct way to measure these drawings, but a question arose, could you actually just measure from the elevations? Yeah, if the elevations are measured to scale and you're satisfied with that and you can read the drawings correctly, there's no reason why not. Most people will read the plans a little bit easier than they'll read an elevation. So all of these little kind of extension pieces, for example, are difficult enough to pick up off the elevation. So the depth in plane is more difficult to read. So if you can read them well, if you're used to it and you're in a hurry, then by all means use the elevations. But for more accurate measure, I would suggest you use the plans. Which is what we're going to do now. So in terms of result, we're measuring the 215 mil thick, that's 215. Your block walls have either, generally speaking, either 100 mil thick, such as the internal walls there between the wardrobe and the storage, or 215 thick, such as those walls there externally and these staircase walls. You can also measure, you can scale them and measure, and you can see a note there for the steel head 203 by 203. So a 203 is an appropriate size for a 215 block wall. 7N refers to the 7 Newton concrete strength of the wall. So result, vertical area. So area would give us the area on plan, but we want to measure the area as it's in the vertical plane, not in the horizontal plane. If that makes sense. So vertical area gives us the length of the wall, and it states a dimension for the height, and it multiplies the length by the height and calculates the vertical area as it's standing. So we'll use the vertical area. If you were doing this, we're doing all of these separately. If you were doing this in just one big long sheet, if you're doing element 19, element 21, element 22, as some people do, I asked you to do them separately for this, but sometimes people do them all together. If you were doing that, then you could just copy and paste that shape, but we're going to end up doing the shape again. So it only takes a couple of minutes to do it. So as we did before, we'll start with the external corner. We're in polyline, and we just start clicking. Click, click, click. There you go. So that's the beauty of modern technology. I can pause there so you don't have to watch me clicking. So once I get to the end, I just close that with the right button, and they all add up, and I can just widen that there and see what my measure is there. So I have 162 approximately meters squared for the ground floor, and that is with the assumption there that it's 2.7. Now, I'll show you where that assumption comes into play if I click on the shape, just like we did last time with the thickness. They have certain assumptions. So their wall height in the detailed section, it has 2.7. We need to establish what is the exact height, and we do that by looking at the sections, which we're going to do now. Click in here to the sections. I should be able to see floor to ceiling height. And I'm looking for, I did say before, I'm looking for approximate quantities here, but I'd like to show you how to change the height just so that you're able to do that in the future. It's not turning for me. There you go. Okay, so there is a couple of things in here. Look, it says there that the floor to ceiling height is 2.7 to the underside of this section here. We're actually going to measure from the floor slab to the top of the first floor slab because we're measuring through the concrete slab section, if you like. So the best way to do that is actually just to write down here test height, and I can delete this afterwards. I'm just going to get a test height, and I'm looking for the vertical height here, so I'm going to use length, and I'm looking for what it is in the shape as opposed to in the summary, because it's going to be rounded up in this summary. So I'm just going to click on the slab. I'm going from one slab to the next. So I'm measuring from the ground floor slab to the first floor slab. That's giving me there roughly 3055. So if I click in there, should be able to see what that is. 3055. Yeah, 3055. So look, I'm going to use that dimension 3055. So back in here where it says shape 1, instead of 2700, I'm going to type in 3055. 3055. Okay, and that's giving me 182 meters squared. We're going to deduct out the windows separately. We'll do that at the end, but first I'd like to get the first floor. So I've just measured the ground floor there now. I have to measure the first floor, and then I have to measure the gables. Okay, so I'm going to go ahead and do that now. Click into the first floor and do a similar takeoff on the first floor. So you can see on the first floor, there's only 4 corners in the first floor. So I could do the 4 corners, or I could do something which is nice and handy, which is a rectangle. So I just click on rectangle. I hit one corner, I hit the opposite corner, and bang, that's my first floor done. Happy with that? So now I have to make the same adjustment because my default is 2.7 there, and I'll have to go back and just adjust that sections, passive house, Yeah, what's that working out at there? So 2625, but that's a stated dimension, and I have a little bit messing. It's probably not a million miles. I've got a little screed in there, and I've got a few other bits there. So let's just actually take a test height there and just be accurate. Part of this is demonstrating your ability to be accurate, I suppose, and also part of it is just getting on with the job. Excuse me a second while I press escape there. Make sure you have line selected there. I'll try that again. Test height. So from the slab, I'm going from the structural slab rather than the screed. So where that blue line stops, and I'm going as high as this little block there. 2805. Okay, that'll do me. 2805. Happy with that. Bob's your uncle. 2805. Go in there and make sure you change that. Click on back in here and click on shape 1, first floor, and 2805. It's only 100 mil, doesn't make a huge difference, but if you were doing maybe 100 houses, could be a load of blocks maybe. Now I'm going to go in here and I'm going to measure my gables. And because this is an approximate measure, we said before that we would do, you can do a little estimate there, 4 times 2 times a half, and you can change the wall heights and all that kind of stuff. But look, for its approximate measure, I'm happy just to get the length and the vertical area and measure it once as opposed to twice. Okay. So what I mean by that is a gable is usually half the overall length by the height. So if I get this line here, it's vertical area. If I get that dimension there to there, and if I do my test height there, test height gable, again, what you'll find is that there's different ways of doing all of this. What's important is you understand the principles behind it. So that's 2.5 meters high. That's 2397. Okay. So I can take that vertical height and put it back into that shape, which is shape 3. And if I say 2.4 approximately, that means that I've got a gable height of 2.4 and I've got length of whatever that length was there, 5 something or other. And instead of saying I'm going to deduct half, I'm going to deduct that void and that void, which is roughly half, and then I'm going to multiply the whole thing by 2 because I've got 2 gables. I'm just going to leave it as it is. So that's the equivalent. 15 meters squared means that each gable is about 7.5 meters squared. Okay, so I'm happy with that. That's my vertical area. Leave that alone. Now I need to look and see, is there anything else in there? No, that's it. Okay, so roughly 325 plus or minus maybe 5 to 10%. Next thing into is my concrete lintels. Lintels are measured in number. You enumerate them and you state the length. So before I measure my lintels, I'm looking at my elevation and I'm noticing that all of these windows are very similar in width and height. So I can make an assumption that they're all the same, so they'll all have the same lintel. And before I measure that lintel, I'll have to actually deduct the area of those windows and the area of the doors from our measure. So the vertical area function, it's a little bit difficult to use deductions in there. It's complicated, it's overly complicated. So I'm going to put a little comment down here, deduct area of windows. I'm going to manually measure these. I'll show you what I'm going to do now. I'm going to measure them in terms of standard area as opposed to vertical area. I'm going to measure each one and multiply across. So let's say there's 1. I'm going to factor in the factor of them. So on the front elevation, I've got 1, 2, 3, 4 that are the same style. Okay, so just go factor 4. And then I go to the next one. And in this case, I have slightly bigger, 1.8 meters deep. And I have 1, 2, 3, 4, 5 of those. Factor 5. And that's on the front elevation. Now, before I move away from those shapes, I'm going to look at the rear elevation. The elevations are in the plan. So the front elevation is on the ground floor plan. The rear elevation is on the first floor plan. So I'm going to stick with these plans now. And I can see that's slightly different. That's slightly different. That's very similar to the upstairs window. So I would just go 6 of those. And that one is very similar to the ground floor window. So I'm going to say 6 of those. So I'm just adjusting, making my adjustments. And when I look at the two gable ends, I can make those adjustments as well. While I have this drawing open, I'm going to measure these windows here. So I'm going to say bang, bang, and I'm going to go by 2. So that's a shape there. I'm going to factor that by 2. That's the one to the side is the same. And then these here are also the same shape. So I'm going to go, I'm in my rectangle shape. I'm going to go factor 2 there again. So now I've measured that, 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 that. And now I need to look at my gables. So I believe they're attic and side elevations. Should have some side elevations in here and see, do we have anything similar in there? Just rotate my plans. Again, that first floor window, and that's slightly different. So I have another one of those first floor windows, which is great. A couple of doors in there. I have another one of the ground floor windows, and then I have these new style windows. So that first floor window, that's my first one there, so I'm going to adjust that to 7. My ground floor doors are including this window here. It's a different shape, so I'm going to do that one bigger there. 1662. A good thing about this as well is it gives you the stated dimensions. So when you go back to check your lintels, you have the length and you just add on the bearing. Mine is set up, by the way, yours may not be set up to display the dimensions. I had to go back and put that in somewhere. I think it might be in view or data. Play around your settings. Another shape that I have here then, so I've measured that one, is this window here. A long horizontal window. I have a few of those. I have one in there, one in there, one in there, and one in there. So 4 of those in total. And then I also have this ground floor window here. So again, don't get too bogged down. If you're slightly out compared to me, I might be slightly out compared to you. I'm doing this in a bit of a hurry. But what this is also doing is it's giving me a list of all of my lintels. I've got 7 of that type, I've got 7 of that type, so I don't have to go measuring them again now. And it's giving me an area of all of my shapes. So I've got roughly, I remember from previous it was around 58 meters squared, roughly 57 square meters that I'm deducting from my vertical area. So if I go back into this shape here, I'm deducting the area. Essentially what I want to do, I'm doing 2 things at the same time. I'm measuring the length of my lintels when I go in and do the area measure. It gives me the length of the lintels before I add on the bearing. The bearing is both 2 sides, either side. And then I also have the measure for the deduction. Okay, so I'm going to type that in here, deduction, deduct, Any D's are in deduct. D-E-D-U-C-T, deduct. Windows, and that was measured separately. And that is 58. I'm going to manually write that in as a subtotal. 58, no, 58, no. Where is this? 58, I did this before. Okay, so I had to come up with a little bit of a fudge there to get this to work. So to get it to work, you can see there it's all highlighted in red. I'll just delete that and show you what I did there. So I manually went into this one here where I had my 323 meters squared. Just notice the area there. I manually wrote it in there, deduct windows, measure separately, whatever. I have to manually write in the factor and the length and the width. It gives me the subtotal. That's where I was getting caught up there. So it's 58 meters squared, which is the same as saying it's 58 by 1. So 58 by 1 should give me 58 meters squared. Now, if I leave it alone like that, it adds it on. But up here, you have a column that says minus. It's a deduction. So if I click that minus, turns everything red, and it deducts it. I now have 265 meters squared net. So that's what you should be sort of aiming for in around that. Okay, so I'm measuring the concrete lintels now, and what I'd like to do there is just maybe insert a space if I want to insert a little gap there. I'm going to start off with the smallest window, and if I look at my first floor plan, smallest window, they're actually stated on the dimensions. They're up there on the first floor plan. Sorry, it's open there. The dimensions are actually stated on them, and you can see there it's stated as being a meter wide. Okay, there's some of them that are a meter wide. I think the majority of them are a meter wide. So that's my smallest window. Internally, I have doors that are 900 wide. Externally, I have windows that are a meter wide. Every time you have a window width, to get the head width, you have to allow 225 on either side, because the head goes in, it extends in 225 on this side and 225 on that side. That's a half block. So you measure up the width plus 2 times 225. So 2 times 225 is 450. So in this case, my stated length, remember we said that we just state the length and enumerate them. My length is, sorry, they're 225. They're 2, I'm going to say 215. Let's lose the correct terminology. 215 wide. And they are 1.45 meters long. And they are in number. And in terms of quantity, I can go around and I count them all up, or I can just look at my previous measure I did for the windows, and I can see there, I can adjust this as I go through, but the first two categories there are both a meter wide. So I'm going to start off with the first two categories, and then I'm going to check the others as I go through. So for now, I'm going to just say 14, quantity 14. Okay, and then I'm going to check and I'm going to see what kind of heads. Do I have concrete heads or do I have steel heads for anything over a meter? So the rule of thumb is if you have a steel head, it should state that on the drawing. So if you look at this window here, for example, that's a 2 meter wide window that's up there in the ensuite, and a 2 meter wide window in the master bedroom. Those heads are stated on the drawing. There's this dashed line that goes through, and there's this description there, 203 by 203 by 46, that goes through. So I'm not measuring the steel at the moment, I'm just measuring the concrete at the moment. So I'll just come back to those in a couple of minutes' time. I'm just checking through this plan. I've measured all those small windows already. So there's nothing more on the first floor plan, and the question is, what's the ground floor plan like? Again, generally speaking, different engineers differ, but once you go over, say, 16 or 1800, tend to go for steel. Front porch there's no reference to steel there. Window seat, no reference to steel there. No reference there. I'm just manually checking through. I can see I have one here, a steel there. I've no reference to a steel there, so I should have a concrete head that's longer than standard there. It's about 1600. I've steel in there. Okay, and I've steel elsewhere. So the next one is that side elevation entrance door into the porch. So if I go back to my side elevation, in my case, my dimensions are stated on the drawing. You might have to check around with yours there. I have 1663 for my width, and I'll allow twice 450, so that will be 2050. So I'm going to say another one there. I'm going to insert my little blue insert item. 215 wide by what do we say there? 2050, 2.05 meters long. That's a count, and there's just one of them. Okay. Now to my steels. One big steel going across the back that I have to make sure I get. So I generally start with the steels on the lower end of the scale. So the first one I'm going to look at is the one I just saw there a minute ago, which is there, this one here. So I'm going to check the length on that. I sometimes do a test length and then delete afterwards. I'm just stating the length. So I'm not measuring the length, I'm stating the length. So I'm looking at the opening and I'm going to add on 450. So that's a 2 meter opening and I'm going to add on 450. So that's 2450. 2450. So it's 203 by 203 by UC 46. Let's put it in the way that they say there. 46 kg UC. Now just have a quick look and see. We're going to put that in count. Have a quick look and see how many of them are there. Are the others also UC 46? That's 46. Those are 46 as well. Okay. So from a ground floor plan, I've got one there. I've got one there. That's longer. That's longer. I have to check that dimension there. Check that dimension. Check that in my steel. Delete that afterwards. It's actually 2.2. That's a 2.2 window. So I'm going to put that in there straight away. Okay, so I just pause for a sec there just to read the drawings there and just double check these dimensions. So a lot of the dimensions are actually stated on. So where you can see there I have 2 meters and I have 450 on top of that says 2450. I've gone along and I've counted them all and I have used that little pink color to indicate the count. So I have 2 on the ground floor and I have 3 on the first floor. And then if I go back to ground floor, I have another 2 of these that are slightly bigger. It's the 2650. So I'm going to change that color to a slightly different color, maybe yellow, just to indicate that they are actually 22. You can see there from the stated dimensions 2200. So they're 2650. If you made a mistake there and you got them all the same size, you essentially have 2 steel beams that are a couple of 100 mil too short. It should be a pain in the neck if you've ordered them and they arrive on site and they're the wrong size. Could cause delay and disruption and all the rest. Okay, now we mentioned earlier on that that's those ones there. We'll work our way up to the biggest ones. So there's one there. There's I have a stated dimension in there, 4634. That's for the overall. So I'm just going to check and see what's that. Is that 406? It is 46 kg. So I can copy and paste. And within there, I'll just take that out for a sec. Just deleting the quantity that was attached to that. I'm just going to double check the length of that first before I give it a description. So that's 3447. That's quite a big steel. 3.45. So I have to add on 450. So that's going to be 3.9. You can see that that's quite a big steel, almost 4 meters long. 39009. This is where now you have to decide you can stick in your description with millimeters or length, millimeters or meters. Okay, that's fantastic. And then we've got two over here which we've measured. We've one last one, which is this big long one along here. This is a bigger steel because it's it's actually 107 kgs per lineal meter. That's a massively heavy steel, but we need to measure that. Okay, so let's write that description in there. It's over between the kitchen, dining, and the living room. Huge big beast of a thing, 254 by 254 by 107 UC. And sorry, just go back to this one. Just go back to that one. There was just a one of those. Count. There's just a one of those. That's that one there. Change the color. And then we have this big long beast of a thing. Give that a different color. Give that maybe bright green. And that's a 254 by 254 by 107 UC. And we're going to get the length of it. Firstly, just from there to there. 6850 plus 450, which is 7.3 meters by 7300 millimeters long. Big steel. It's one of them. Why am I mentioning the size of steel so much? Probably because the rest of the steels you could probably manage. 2 people could probably lift them in, but this one here you're probably going to need some sort of lifting aid, teleporter, or possibly even a small crane. Delete that quantity and change that to number. And there's one of them. That should be our steels. Now, why is it? Why is that? That's inside, in the kitchen dining. Why is it measured in external walls? Because its main function is to carry the external wall above it. That's what that steel is actually doing. So this wall here is actually an external wall, and it's carrying its external wall above. Hence the reason why that's where it is. Alrighty. Okay, that's your external walls. That's it. So we've measured our steel lintels, we've measured our concrete lintels, we've measured our walls, we've deducted our areas. That's you done. Thank you.